Welcome! We're about to get hands-on with a really fundamental rule of chemistry. We're going to break down a simple, but honestly pretty powerful experiment to see exactly how temperature can change everything when it comes to mixing things together. So let's start with something I bet you've noticed 100 times. You stir a spoonful of sugar into a piping hot mug of tea, and poof, it's gone. But try that with a chilly glass of iced tea. You just get that sad pile of sludge at the bottom. So what's actually going on here? Well, it all boils down to this one concept called solubility. Now, it sounds all scientific and complicated, but it's really just a way of asking a simple question. How much of this stuff can I dissolve in this liquid before it just won't take anymore? The stuff, by the way, is called the solute, and the liquid doing the dissolving is the solvent. Okay, so that leads us to the big question for our investigation today. We have a hunch there's a connection between heat and how well things dissolve, right? But how do we measure it accurately? How do we take that everyday observation about our iced tea and turn it into real, hard data? All right, let's dive right in. We're going to walk through the exact method scientists use to pin down this relationship. And it's actually a pretty clever process when you see it all laid out. The whole experiment really hinges on making something called a saturated solution. For this, we're going to use a solid called ammonium chloride. And making a saturated solution is just what it sounds like. We add so much of it to water that the water absolutely cannot dissolve one more crystal. The solution is completely full.
The process kicks off like this. First, we add way more ammonium chloride than the water can handle. That's what we mean by excess. Then we give it a real good stir and pop the whole thing into a water bath that's held at a perfectly steady 25 degrees Celsius. And that 5-minute wait, super important. It makes sure our solution is at the exact temperature we want to test.
Now, if you look at this setup, the water bath is the real hero. It's not just some random beaker of water. It's a precision tool. It lets us lock in the temperature and keep it perfectly steady, which is the most important variable we need to control in this whole experiment. So, our solution is ready and waiting at a perfect 25 degrees. Now we need to grab a sample. We start by weighing a little ceramic dish called an evaporating basin. Then, we very carefully pour some of our saturated solution into it, and you got to be careful not to get any of that undissolved solid from the bottom. And then, we weigh it again. The difference between those two numbers, that's the exact mass of the solution we're working with. And here comes the really clever part. We gently heat the basin. The whole point here is to evaporate every last molecule of water, leaving behind only the pure, dry ammonium chloride that was dissolved inside. Once all that water is gone, we weigh the basin one final time. Okay, so we've collected all our measurements. The weight of the empty basin, the basin with the solution in it, and finally, the basin with just the dry solid left over. Now it's time to crunch some numbers and turn all these raw measurements into something that actually means something.
And we do that with this formula. Solubility is just the mass of the solid we were left with divided by the mass of the water that we evaporated. Then we multiply that by 100. Doing that gives us a standard value that we can compare. Basically, how many grams of the solid can dissolve in 100 grams of water.
So check this out. Here's the actual data from an experiment that was run at 25 degrees Celsius. We have our 3 key measurements right here, so let's put them to work. First up, let's figure out the mass of the solid. It's just a simple subtraction. We take the mass of the basin with the dry solid and subtract the mass of the empty basin. So that's 81.5 minus 78.6, which gives us 2.9 grams of ammonium chloride. Next, we need to know how much water we got rid of. Same idea. We take the mass of the basin when it had the full solution and subtract the mass of the basin with just the dry solid. So 89.3 minus 81.5, and that equals 7.8 grams of water. Now we have the 2 pieces of our puzzle. We just plug them into the formula. We take the mass of the solid, 2.9 grams, divide it by the mass of the water, 7.8 grams, and multiply the whole thing by 100. And that gives us our final answer, 37.2. So what does that number, 37.2, actually tell us? It means we've figured out, with real precision, that at 25 degrees Celsius, you can dissolve a maximum of 37.2 grams of ammonium chloride in 100 grams of water. We've answered our question. But, and this is a big but, we've only answered it for this one specific temperature. Of course, science is all about finding patterns. A single data point is just a fact. It's not a story. To really get what's going on, we need to do this whole experiment over and over again at different temperatures, say 35 degrees, 45 degrees, 55 degrees, and so on, and then plot all of those results. And when you do that, you get this, a solubility curve. Each and every point on this line represents the result of one of those complete experiments. It gives us this really powerful visual of the relationship between temperature and solubility.
And using a graph like this is super simple. You just pick any temperature you're curious about on the bottom axis, let's say 30 degrees. You follow that line straight up until you hit the curve, and then you just trace it straight across to the side axis to read off the solubility. It's that easy.
We can even use this graph to kind of check our own work. See, if we look up 25 degrees on this sample chart, it says the solubility is about 32 grams per 100 grams of water. Now that's a bit different from our 37.2, but that's totally normal. You know, experimental data always has a little variation, but it proves that the method works perfectly. So, after all that measuring and weighing and calculating, what's the big takeaway? How does all this lab work connect back to our simple cup of tea?
Here it is, all boiled down. First, for solids like ammonium chloride, and yeah, sugar too, solubility goes up as the temperature goes up. The hotter the liquid, the more stuff it can hold. Our experiment shows the exact method we use to measure this, and that solubility curve is the best way to see the whole relationship at a glance. And this is precisely why your hot tea can hold way more sugar than your iced tea.
And all that leaves us with one last little brain teaser. We've figured out the rule for solids. Hotter means more soluble. But does that rule apply to everything? Think about a can of soda. What happens to the dissolved gas, you know, the fizz, when it gets warm? Does it also get more soluble? Or less? Now that is a great question for another day.